Thomas is going to give a presentation on SMPTE 2110 and next-gen audio codecs. Thanks for coming.
Thanks. Thanks for having me. So my name is Thomas Burnichon. I'm ATEME's VP of Innovation Strategy. And today I'll talk to you a bit about next generation audio in the context of 2110. So I'll start with a quick intro on the format and rationales behind it, move on to audio production workflows and see how they change or actually not with 2110. Move on to NGA specifically and approach how 2110 can actually help and make it much easier to deploy NGA. And I'll conclude with an example with the Eurovision Song Contest. Obviously, don't hesitate to ask any question. So, why 2110? I fear it has been vastly discussed already in this conference, but basically, the IT industry has been doing great progress over the last 40 years, huge economy of scale, and also great performance improvement. So at some point, it made sense to drop the traditional SDI matrices, custom hardware, very pricey, and move on to commercially available off-the-shelf hardware, basic switches, and use that not only in distribution like we did for the last 20 years, but also in production. That basically allows you to connect all your production equipment, so all your sources, the receiver, the mixer, the authoring software, and the encoding. So at ATEME, we are on the encoding part. And do all that with plain and simple switches. Of course, to do that, you had the economic benefit, but there's also performance gains. And we'll get back to that, but latency is one. 2110, by itself, by its architecture, is providing benefit in terms of bandwidth savings. So I think the blanking, for example, is something we stop continuing to send over all the time. That by itself is nice, reduce the bandwidth usage. But, and that's specifically useful for audio, the ability to do individual pickups is tremendous. Not having any more to disembed and re-embed audio from the video as soon as you have one little audio processing step is a big deal. And while there are still challenges, obviously with cloud, we just mentioned that in the previous presentation. The one before actually also mentioned the use of H.264 within a 2110 use case. So there are now at least a possibility of using cloud deployment, which is an overarching trend in our industry. While basically plugging a SDI cable in your cloud provider is kind of difficult. So at least doing that over an IP stack while still challenging is something that we can look forward to. So now moving on specifically on audio, the interesting thing is that at least functionally the audio workflow didn't change that much with 2110. You still have all your sources, you feed that to mixer, you move on to authoring and potentially processing if you need it. And once you did all that, you move on to an emission encoding. You monitor all steps of the workflow. And in the end, that's very classic. What's happening under the hood, though, is really different. That used to be all SDI links. Now, everything is connected to central switch, or I should say switches. And as I mentioned, you can do individual pickups. That means you can now have an audio description path that's coming from even a different venue. You can have a freelancer doing your audio description and provide that to, I would say, almost as a side loading to your traditional workflow without having to deal with all the complexity of the video routing itself. you have mixes that can define all your representation, then the authoring can intervene, and we'll get back to that specific for NGA, since there are more powerful rendition you can now create. And once all that is clear, you can move on to encoding. Now, to bring up NGA in that context, I first need to define in a few minutes NGA context. Next generation audio regroup mostly two big codecs, Dolby AC4 and MPEG-H 3D audio. MPEG-H was defined within MPEG, and the main proponent was Fraunhofer, but there are others like Sony and actually even Dolby. One key aspect, well, first let's talk about deployment. Dolby AC4 is used in terrestrial in the US. We deploy over ATSC3 at ATEME. MPEG-H is used in terrestrial in Korea, and is also used on music streaming services, so over the top, usually known under the term Sony Reality Audio, 360 Reality Audio. So you have services like Tidal doing that. And a key benefit of those NGA codecs is that it brings immersivity. So you're all familiar with surround sound, but even 5.1 or 7.1 is horizontal. With those NGA codecs, you are bringing a sense of height. So for a live production that is still channel-based, a use case can be 5.1.4 with basically 4 loudspeakers in the ceiling, 2 in the front, 2 in the back. And the idea is to, again, bring a spatial rendition rather than just a flat horizontal one. And especially in cinema today, but longer term we could see that in live use cases. Besides fixed loudspeaker configuration, you can have objects that actually move around you. So instead of having sound being defined by fixed position, you now have a sound field that is more about direction of sound that can vary over time. That's useful for home cinema kind of setup, but that's actually also useful when you're moving towards immersive use case like head-mounted display and VR. And even if you are listening to these with headphones, by the way. So in VR, you can track the head position. And again, even with headphones, there is technology like binaural that allows to virtualize the speaker position and basically define a sound field that can follow the user and therefore be much more immersive. But while immersivity is a key selling point of NGA, the personalization is also something very important. Things like dialogue enhancement is really important. Hard of hearing people always complain that music and effect kind of are overcoming the dialogue. Well, in NGA, you can have specific tool to isolate dialogue and make that transition more intelligible for those users. Same goes for audio description for visually impaired people. Within NGA, you can easily, and without having to retransmit the complete audio experience, just add the audio description on top of it and let the user, well, not only select it, but even configure it the way he wants. So, for example, on the left or on the right shoulder with variable number of configurable volume and so on. You could even imagine that they could choose between two types of voice, like a feminine or masculine voice, depending on what they like. That brings me to the next point, which is flexibility. Since no sound is a sound field, you can adapt it by rendering it on the client side to adapt to the final setup of the end user. So that means you don't need to actually exactly place your home speaker like you used to. You can adjust them and let the rendition take that into account if your room has some specific constraints. And again, this is also applicable for headphones using binaural. What that means is that you don't need anymore to send different streams for all the experiences. You can send base stream that can, at the rendition step, be made custom to the end user setup and also its preferences. And of course, if you look back, some station already had an hard time dealing with variable number of channels between stereo and 5.1. So in order for all what I just mentioned to be feasible, all this dynamic in the audio content, you need to have ways to adapt and adjust dynamically on the encoding side, and I'll get to that. So now looking at 2110 in particular with regard to those aspects, the first one about immersivity. In SDI, you were usually bound to a limit of 16 channels per link. And as I just mentioned, with NGA, you want to go to a much higher number of channels. If you want a 514 mix and you want to present it both in Spanish and English, that's already 20 channels you need to move around. That's really difficult to do in SDI. With 2110, I think a flow is limited to 8 channels, but you can have as many flows as you want, which unlocks a lot of possibilities in order to basically provide a more immersive experience to the end user. Now, for the actual dynamic aspect I mentioned, there is upcoming standard 2110-41 that allows to feed dynamic metadata to, well, anything in the production environment, but in our case specifically the encoder, to feed it custom parameters that are generated dynamically by the authoring tool, and that can then be de-encapsulated and fed to the encoder to make dynamic decisions that will then be transmitted down the distribution path down to the end user decoder and renderer. And that's really powerful and actually unlocking a lot of the NGA potential. That's not to say it's completely not feasible in SDI. In fact, we did deploy SADM, I'll get to that, so this dynamic payload over SDI, but it's eating up one channel, and you always have the risk to have something in the audio processing chain actually hurting the metadata. When you send metadata on an audio link, which is meant to be audio, things can happen. You can actually impact and corrupt the data. Flexibility, mentioned that a few times, having individual pickup of additional experiences that can sometimes be generated differently and even somewhere else than the main experience is really big. Audio description comes to mind in that case, and that's an easier thing to organize within a 2110 ecosystem. And I mentioned the idea of dynamically configuring the encoder. So if we dive a bit more into the 2110 NGA workflow, it's similar to the workflow I mentioned before, but the idea that you will use -30 or 31 for your audio sources, you'll mix them, provide that again as a 30 or 31. And the important piece is the one in the middle, in this presentation, is the link between the authoring and the encoding step, which, of course, has the payload still in 30 and 31, or 31. But you have a fast metadata path, the -41, which is separate, but that stays in sync with the actual audio payload and describe this payload, and more importantly, its variation and indication for the encoder to perform the right encoding decision. So, typical example on the authoring step, you can define a music and effect bed, like a 514 kind of Atmos based. And on top of that, have various languages that can appear and disappear or object from the crowd if you want to provide an ambient sound on top of the actual concert or sport venue. Then the encoding can take care of that and prepare its delivery, which actually I'll go into more details on this slide. So that's focusing on the encoding step. On the previous slide, you had the encoding, so in our case, a Titan Live. You can feed that with all your video 2110-20 links, audio links and 30 and 31, 40 with the data. And now with the 41, you can actually provide the serial ADM dynamic metadata to the encoder that will tell it how to deal with all the audio you provide. You still need some custom reordering because, again, the encoder needs to be fed with everything. For example, the sidecar audio description I mentioned, you actually need to physically, well, physically, still in software, but you need to feed it to the software encoder, being the AC4, the MPEG-H encoder. You can do channel swap if needed, because some of the production constraints make it difficult for the second language to be at a given configuration. With the SADM, the encoder will perform its job in a dynamic fashion. And based on that, we can go to the next step, which is packaging and mixing, where based on the information provided dynamically by the encoder, you can expose high-level information that will help the player down the road make decisions. So things like codec profiles, complexity, so kind of number of channels of the output, so that the player decides if it's worth even trying to parse and go into the elementary stream and decide what to render. And of course, there is also the metadata on the elementary stream itself that will describe in more detail every element, including the additional one, like audio description. That will then, once detected by the player, be exposed to the end user. To go into more details about because I mentioned a lot SADM so far. So first, ADM, audio definition model, is defined at ITU and is a description that is vendor agnostic of the payload of the NGA, so that it can excuse me, allow some interoperability in that domain. It was a strong request by people like France Television. Now, this ADM model, you serialize it as SADM, S stands for serial. So the idea is to have those same description, but in a live use case that can vary dynamically. And as I mentioned, this SADM, you can have it on an audio channel in an SDI link, but that's causing all sorts of issues. Another way is to actually frame that in MGA, so a SMPTE standard 2127-2, and then include that as a payload of 2110-41 fast metadata transmission. Mind that those, as far as I know, standards are still being worked on. In our experience, there are even slight differences between MPEG-H and Dolby Atmos ADM profiles. So we have links here if you want more details provided by both Dolby and Fraunhofer. But those differences are small enough so that an encoder can actually perform a switch between the two, which is one of the key motivation that France Television and others within EBU had in mind in order to keep the playing field even in the production of audio signal and allow competition in that domain. More references. if you want to dig more into this, Dolby published documentation, some sample stream, and their authoring tool, which is SMPTE Studio, as far as I remember. Fraunhofer has their own authoring suite that you can also access online. And if you really want to dig more into all the vast NGA and 2110 domain, there is an excellent workshop that was organized last year by EBU. So you have some content available online. You can contact Paula at EBU to get more detail. We participated in this event in November as a tech partner to both Dolby and Fraunhofer. And we felt it was a good occasion to kind of meet the whole ecosystem and understand the challenges of it. Because again, not everything is finalized. So there is some interop discussion to have moving forward. I'll conclude with one example, which is the Eurovision Song Contest. So for some of you that might not be familiar with that event, it's held yearly by EBU, the European Broadcaster Union. Just to give you an idea of the scale, the viewership of Eurovision is actually larger than the Super Bowl. So it's a big thing. I know it's a song contest, but there's a lot of people in Europe watching Eurovision every year. And by definition, it's an event that lends itself very well to having multiple languages, because there are, every country basically sends a music group to the event. So within that context, having the ability to add additional languages was really good. So the acquisition, you had singer and musician, but also the venue. You had different mixes. And on the authoring side, commentaries, like I mentioned, were added in I think 5 languages. We'll get to that in a moment. A basic preset was provided for everyone, but as I mentioned, the beauty of that is that you can actually still expose control to the end user to tune it even more to its individual needs. And we were encoding all that based on SADM metadata set. So that's Tektronix analysis of the output from our encoder. And it might be difficult for you to see from a distance, but you'll get the slide. And what's interesting, so in the competition, you have 3 kinds of use cases. You have a demo reel from each group, and then their live performance, and then some ads. For the demo, since it's something prepared in advance, you can go fancy with Atmos mixes and stuff like this. And it's exactly what we did. So you have a 514 bed, which is, so in that use case, it's MPEG-H. But it's still, so it's not Atmos, but it's still an immersive experience. And on top of this 514 bed, you add English, French, German, Portuguese, and Italian. By the way, again, the beauty of this approach is you're not even forced to broadcast everything. Like in France, you could broadcast French and maybe English, but some people might, like the Portuguese diaspora in French is really big, they could fetch the additional object from an OTT line instead of the OTA. So that's one of the hybrid use cases allowed by NGA. And the preset based on those groups were as follows. It's on the bottom part of the slide. You have a default experience with the 514 and the dialogue you can select. You had a dialogue enhanced version that people could get where the dialogue was increased for the hard of hearing. And finally, you had a no commentary option for those who don't like to hear comment during the performance. And of course, that was user selectable. So that's a screenshot of the prototype UI, where you could select on the first line the language, but then decide how prominent it was. and also define where you wanted it to be anchored, on the left, on the right, and also up and down, with basically a cursor to select this position. So that's just an example of how NGA can be leveraged, and 2110 can definitely help making this a reality moving forward. Before I move on to Q&A, I'd like to acknowledge Luca Gregory, a colleague of mine who couldn't be here today, but who prepared the slide. So thanks for him. And yeah, if anyone has a question, I'll be glad to take it.
Okay, oh, yep, Ken.
Yeah, thanks, Thomas. Good presentation. Ken Terry with Dolby. Just not really a question, just to elaborate on a couple points in your slide that clarify for the audience where things are headed. Dash 41 and its companion standards to fully enable this stuff are in fact progress, and we do hope to publish them in 2023. But just make it clear that I think, we work with you on some of these demos. There is a method already in place. It's been a while since I've given the presentation, Brad, but need an update for the group. But we can get this done in an SDI-compatible way and still deliver many of those features you talk about with advanced audio. The goal of Dash 41 is to fully enable all the features of these advanced codecs. But a lot of the things that have been put in place in the demos can be done in SDI-compatible fashion via 30 and 31. So that's one point. So Dash 41 is just an evolution of that same thing. But if you're in a system that still relies on SDI, it doesn't limit you from doing much of this. Second of all, there's a lot of work in SMPTE happening on the file-based side to enable this metadata to flow back and forth from live and file workflows. And that's where Dash 41 and its companion standards come in. SMPTE's recently published the MXF's mapping of SADM data to MXF. Which is a key piece of making it interoperate with these things, and there's more work coming along with IMF profile, IMF plugins, and as well as full ADM data. So we have a way of doing a complete open standards-based codec-independent workflow, deliver it, both file and IP, have them translate back and forth, and then fully enable not only these features, but many of the advanced things we're just now beginning to think of. So this is a good step in that progress, and yes, we are making progress, so thanks much.
Thanks. I agree that the next frontier is clearly play out, basically using cinematic content, but within a live delivery ecosystem, will really go beyond what the SDI can do, especially with all those objects. So I hope I was not misleading. In fact, a lot of that so far was also done in SDI, but again, with some limitation. I'm just highlighting in this presentation that we really recognize the work the 2010 groups and committees have been achieving to kind of go to the next level in terms of NGA and really deliver on its on all its potential.
Okay, good. Thank you for that. Thanks for the presentation. And Kent, also, I think it's to be determined, but I hope I'm not premature. Somebody in the board yell out if I'm wrong. But it's likely that let's put it this way. If we have a May-June series meeting, that's likely to be virtual. And that would be an excellent thing, would be to get kind of a roadmap update of kind of the world of audio and the work that you were talking about. So maybe you could consider giving that. That would be great. All right, thank you so much. Great presentation.